Hi everyone, welcome to Parametric Online YouTube channel. I'm your instructor Sabri. Today we're going to do a Spirograph exercise, but before I get to that, if you're just discovering this channel, I upload content about parametric design tools, mostly RHINO and GRASSHOPPER tutorials. So if you're interested in learning these generative tools, computational design tools, please consider subscribing. It helps immensely to support the channel. I also have another announcement to make. In a few weeks, I'm going to start hosting a webinar series. So if you're interested in learning some advanced Grasshopper tools, or if you're just a beginner but you want to get a more hands-on approach, then you can register for these courses that I'm going to be launching. So I'm going to leave a link below this video where you can actually register for these courses online. And I'm going to be contacting you via email in a few weeks, and we're going to work together on advanced Grasshopper scripts. So if you want to learn, let's say, other plugins, pufferfish, kangaroo, lunchbox, or anything you name, we're going to be able to work on exercises together, and I'm going to be answering all of your questions. So let's get to today's exercise. So before I start, what is a spirograph? So if you remember from maybe your childhood, there used to be these sets of rulers where you can actually have custom gears, and by having these sorts of cyclic motions, you can output custom shapes, right? So these are all parametric shapes that are plotted by that type of radial motion of the gears. So we're going to build something that is similar, and we're actually going to use this sort of component that we're going to build, and we're going to replicate it a bunch of times, and then we're actually going to develop this together. So we're going to embed some parameters, custom parameters, and we will be able to customize the output of the script. So you can see it's actually really interesting. Plotting a lot of different diverse shapes. You can also customize rotations, kind of the influence of the shapes, as well as maybe the interpolation of the points, right? How we want to plot these forms. So let's begin. I'm going to create a new script, and we're actually going to start by a point. So let's say construct XYZ. Then I'm going to have a plane on that coordinate system, and we are going to essentially start rotating these planes as well. So might as well just start building them with rotation. So I'm going to give it all the way up to 360, and we want to work with angles. So let's lock it to degrees. Then I'm going to create a circle here. And that circle, let's give it a radius of 300. All right. So when I evaluate this curve, we can actually see how the topology is going to change. So let's see. When I rotate it from 0 to 360, you can see that it's actually rotating in the counterclockwise direction. So I'm going to keep rotation at 0. The radius is at 300, and this parameter at 0 as well. So how do we build the second second circle, sorry, on top of this? So let's grab the area of this circle. So I want to essentially get the circle as the only input, and we want to develop a 2-point vector from the center of the circle to the evaluated point, and we want to move the evaluated point using this vector, but we want to do a vector amplitude and specify the radius of the second circle. So let's make it 50. 50 is actually a bit low. Let's make it let's make this slider a bit larger, all the way up to 250. All right, and I want to place a circle there. But before we do that circle, we can also do rotate plane there. We can also specify an XY plane, but it's not a must because I mean, if you just rotate a point, then it by default rotates the XY plane there. So we have the angle coefficient here. Let's go ahead and assign it to a number container, pull this here, and use the same number container but multiply it with a coefficient. So that coefficient is going to determine the ratio of how much we want its influence to be on the second rotation. So this goes here, the number goes here, and this goes to the angle, and then we can plot the second circle and its radius is going to be here. So there you go. So we have two tangential circles. So if I change this, it grows from the boundary, and if I change the evaluated point, it also rotates. This is all the way. Oh, this should be actually not simplified, but reparameterized. So let's do it like this, and this parameter should be between 0 and 1. There we go. So 0 is here. So we have these two plugins, these two parameters for the second circle, and this circle is defining the input, and this 0 is pretty much actually fixated. So what we can probably do is keep it here like this, and maybe we can define it as a cluster. So if I right click here and make it a cluster, but it doesn't create the output. So let's define a curve here so that we enforce some output. Right click here and make it into a cluster. So there we have it. So this cluster now is something that we can replicate a bunch of times, and we can customize the amplitude and this multiplication coefficient, because we're getting the angle to it anyway. So I'm going to make a copy, and the C and the G, they come from the circle, so let's plug them in as well. So the tertiary circle could be like this, and let's do one more time, and this time we get our final circle. There we go. So we have 1, 2, 3 circles that are added to the first circle, and what I want to do is essentially get the centroids of these two and get another point around the boundary of this. So if I do evaluate curve, reparameterize this, put in another number slider, then I'm going to create a weave function here, manage integer collection 2, and I want to get the area of the circle, which gives me the center, the area of the second circle, get its center, and this evaluated point. So these are the points that are going to be woven, and they're going to actually have the circular motion, and it's going to plot some cool drawings, I think. So this rotation angle, you can see it's going to rotate all the way up from 0 to 100. But what we want is essentially make a range here and define, let's say, a total rotation value of 1080, and we want to do it in 1500 steps. So that will divide that number. So when I connect it here, it will actually output all the rotations simultaneously. So you can see we're actually getting the visualization of all the circular motion, but you can see it's actually all these lines here that we're interested in. And then if we interpolate those lines, we will get some forms emerging. So we can actually play around with how that form is coming up. So let's play around with these radii values. So if I reduce this, bump this up. Let me check this cluster. We are also using angles, so I think that's fine. Let's come in here. This is, let's change this as well. Let's play around with these two. So let's go all the way before, and let's see if I'm missing anything here. This one, let's bump it up. Okay, this one. let's see, I feel like I'm missing something. These are supposed to be 0, 1, 2, 3. That's correct. These points are correct. That's also fine. Let's look at the previous example. I'm wondering where I'm missing. So these are, this is 0.84, 0.5. This is exactly the same. These are degrees. I used 0.5 here. 0.15, 77, and 0.2, 33. I'm wondering if those are magical combinations. So let's go back to the exercise file that we were doing. So this was somewhere here, maybe a bit smaller. Okay, this one is again somewhere here. This is too wide. Let's see. All of these are in angles, so that's correct, I think. I might be missing something. I'm trying to figure out 33, 22, 0, 20, 77, 15. Let's do that, 77.15 and 20, and this was 33. I mean, it shouldn't matter. It should just 84 and 0.5. Let's go with those as well. 0.45. That's also correct. All right, 300. These are the points. And let's see. Do I have in the beginning? No, the rotation is exactly the same. This one, this is the number that goes and multiplies for all the other stuff. The centers are going as well, so we don't need XYs. Oh, this tertiary one is not using degrees here, so I'm wondering, okay, so that might be the issue. So the tertiary one, I actually swapped it to be radians, but we can actually bump this up. Let's make it all the way up to 20 and see if that's going to actually make more effect. Yeah, there we go. So it's actually, the coefficients, they could actually be more than 0 and 1. So if we do, let's say, let's turn off these points, make these a bit wider in range as well so that we can actually see more motion. You can see it's generating a bit more interesting patterns. Let's bump this up as well. Okay, there we go. So by playing around with these parameters, we can now see that we are getting a lot of different behavior, right? So we can just start plotting some of these and see what kind of shapes we might actually generate. So this is too wide, maybe make it a bit smaller. And this is the final point. Okay, let's make this. I'm wondering if the final one adds the touch, so maybe we can keep these low. And then, yeah, that's also pretty nice. I can also go into the cluster and edit those points as well. But you can see that this is actually kind of interactive, right? So we can actually play around with some of these parameters and see what kind of behavior we get, right? So I'm getting here like different types of radius, the different types of symmetry faults happening. So let's switch to, let's keep this actually low, maybe between 0 and 5. So I'm going to keep it at 2.5. All right, that looks good. This one, let's keep it at 2. Maybe the radius is small here. And this one, let's see what else we can generate. I think this should be between 7. Maybe the secondary one, the radius could be a bit higher, but it self intersects now. Maybe rotation. All right, now reduce rotation on the first. Okay. All right, so, well, maybe we can keep this up a bit. All right, so let's output some of these. So I'm going to output this guy too. So you can see it has some interesting motion. These were the previous ones that I was able to generate. So it's kind of like a nice engine, but you have to go with these sorts of rotation parameters or plugin parameters. So basically, like if I think if you rotate it too much, then it ends up not showing the form clearly. So the rotation has to be a bit more gradual. Like this 9 interval is, I think, a bit too much. So if you reduce it a bit, so you can start seeing, like the form closes on its own, but you want to keep it at a location, yeah, where it's like, let's see if it's a bit smaller, then it self-intersects. If we reduce this one, that might be a bit better, actually. Yeah, something like this would also do. Yes, this is, I think, not too bad. Yeah. We can also increase the amount of steps. So if you want it more refined, so you can do 3000. So you can see you get more lines. Here there's kind of a twist happening. Maybe we can also play around with the tertiary one. Like I think the last one, if it reduced, if it does the final motion a bit more gradually, then the form is a bit more clear. Yes. And this is too small. Let's make it a bit larger. There we go. This is another one that I made. So it has a lot of lines, but you'll be able to see these. If you did, for instance, rendered view, you can actually output these as view capture images by using -view capture to file command, or you can always export these to Illustrator and give some sort of a light line weight and then export them as a printable file, like a PDF, for instance. So that was it for this tutorial. As I mentioned in the beginning of the tutorial, if you're a newcomer to this channel, please consider subscribing to support the channel. And I also left a link below where you can register for the webinar series. I hope to see you in the advanced courses. Until next time, I hope you have good time with these tutorials on the channel. Take care.